Previous class we were discussing on that pair branch and peculiar branch, but that's diatomic molecules and linear molecules. So we will discuss today is that difference between diatomic molecules and polyatomic molecules. So what are the difference in spectra? So difference in spectra, you can say this. Difference in spectra between diatomic molecules and polyatomic molecules. So if we first difference is, we can say that here I will write linear. Or this is all diatomic, it's always linear. So diatomic molecule, another is polyatomic molecules. So here what we say that for diatomic molecules, here always parallel vibrations. It means always PR branch, and for this the selections rule is under delta J is equal to plus minus 1. And for polyatomic molecules, if I say this can be, I can categorize into, that is linear polyatomic molecules, another is non-linear polyatomic molecules. So for linear polyatomic molecules, here also we say that two are possible. One is PR branch, another is PQR branch. And this PR branch, this is due to parallel vibrations. And this is similar, like with parallel vibrations means that is same as diatomic molecules. And for PQR branch also possible, and this PQR branch is due to perpendicular vibrations. So we see that for linear polyatomic molecules, we getting that both PR and PQR branch. And whenever you discuss about non-linear polyatomic molecules, we always get PQR branch. And we know that here that selections rules. Here the selection rule is same as delta J equal to plus minus 1, and here delta J equal to plus minus 1 for P and R branch, and delta J equal to 0 for Q branch. Okay, here also same, delta J equal to plus minus 1 and delta J equal to 0. So these are the selection rules for linear polyatomic molecules and non-linear polyatomic molecules, and for also diatomic molecules. So in the spectra, how it will looks, that we will discuss today. So now whenever you discuss about that linear diatomic molecules, spectras will be like this. Here omega knots, no intensity will be there at omega, and here will be intensities will be like this. Let's say like this type of you will get. Like that type of. So here these are that this is R0, R1, R2, R3, R4, and this is, let's say, P1, this is P2, P3 and this is P bar, and here that delta J equal to +1, sorry, that is +1, and here delta J equal to -1, and these are we say that R branch, and these are we say that P branch, and there is no Q branch where no intensity is there. So this is for the diatomic molecules. Now whenever I discuss about that polyatomic molecules, the spectrums will be polyatomic molecules. So the spectra will be like this. So here that dark intensity will come at omega, where here is no intensity, here dark intensity will comes. After that here will be R branch, like this, and here again that P branch. So if you observe here, this the dark intensity will come, this is for Q branch, and this is for R branch, and this is for P branch. And let's say it started like same way, this is R0, this is R1, this is R2, like this, this is P1, this is P2, and this is delta J equal to -1, this is delta J equal to +1, and here delta J equal to 0. Okay, another things what you notice here, that the space means the space is here also 2b, here also it is 2b, but that what is that space is, means the space here also 2b, here also 2b you will get, here also 2b you will get, here also that will be 2b, here also that will be 2b. So what we see that the spacing means that b value is decreasing, so that spectrum is lying more nearly. So what happening here, let's say for polyatomic molecules, that mass is increases, because for linear polyatomic molecules, if I check diatomic molecules, what is say that two atoms are only present, let's say for HCl or any like O2, so two atoms are there. For whenever you talk about a polyatomic molecules, then more than two atoms are there, like H2O, we can say NH3 type of molecules, means more than three atoms, means here mass is increasing. So we know that I equal to, that is mass, that is reduced mass into R naught square. So this reduced mass is somehow we see that M1, M2, M1 plus M2. So if this mass is increases, then this reduced mass increases. If this reduced mass is increases, then I is increases, and we know that B is equal to H square on 8 pi square IC, and if that I is increasing, if I is increases, then B should decreases, obviously, because these are B is inversely proportional to I. So if I is increases, means whenever you increasing the number of atoms, it means you are increasing the I value. If I increases, then B is increases. So if B increases, then if I increases, then B is decreasing. So for whenever you are going from diatomic molecules to polyatomic molecules, we increasing the mass, and it means we increasing the I. It means that we decreasing the B. That's why this spacing, although this is same 2b, but the B value is decreasing. That's why here that spectra will get something like this, where that spectrums, means that peaks are lying very closely to each others. But now whenever we are discussing diatomic molecules, we will get the spectra in a very good distance amount. Okay, so another points we have to discuss, very important point, that is that topic is effect of nuclear spins. Is effect of nuclear spin. So what we say here, effect of nuclear spin, it means that due to nuclear spins, what is the effect in the spectrum of the molecules? Let's say any molecules, CO, or we can say any molecules like O2. So this type of molecules, let's say here, what we say that center of symmetry is there. If we move from here to here, here to here, that center of symmetry presents. If center of symmetry is present, and secondly that nuclear spin of atom is active, then if these two conditions are satisfied, first center of symmetry, if center of symmetry is present and that nuclear spin of the atoms is active, then what we say that the alternate peak of spectra will be missing. Alternate peak of the spectra will be absent. It means that if any molecules, here also you see that here nuclear center of symmetry is there and the nuclear spin of oxygen also active. So here also that alternate peak of the spectra will be absent. It means, let's say, so let's say for we can do these spectrums. Let's say for O2 molecules. So O2 molecules, since here that COS is present, center of symmetry is present, and oxygen also nuclear spin active. So for this case, what we see that alternate spectra will miss. And one trick you have to remember that since this is O2, so two O2s are there. It means that this is O2, number of atoms are 2, so 2 is even. So even number of lines or peak will be, lines or peak will be missing. Okay, so even number of lines means this R1 0 is present and this will be missed. Okay. And this R2 is okay, and this is odd, and this will be R3 will be missing. Like this you will get. So here that previously it was 2b, now that distance will be going to become 4b. Here also distance will be become 4b because alternate even spectrum is missing. Okay, and similarly if you talk about of CO2, then what this is the 3 number of, here also center of symmetry is present and the atoms also symmetry spin active. So here that since this is 3 numbers and 3 is odd, so odd number of lines are missing. Odd number of lines are missing. So here we see that this is 1, so this R0 is missing, and like that if I do these pictures, to understand I will draw a little bit bigger one. So this is omega naught. So here this is, let's say R0, let's say this is R1, let's say this is R2, this is R3, this is R4. Let's say P1, let's say P2, let's say P3, let's say P4. Then for CO2, since the 3 number of atoms and 3 is odd, the odd number of lines will miss. So it will miss. Oh, sorry, I will draw next. So how it will look like for CO2. This R0 here, this is R0, this is R1, this is R2, R3, this is P1, P2, this is P3, P4. So odd number of lines will missing. R0 will miss, R2 peak will be there, this is missing, these peaks are there. This is missing, this will be there, this missing, this will be there. So this odd number like 1, this is odd, it will miss like this. So here also you get see that now this is 4b instead of 2b, it will be 4b because alternate peak are missing. Okay, so this is known as the effect of nuclear spins. So due to nuclear spins, that is, if center of symmetry is present, then this type of alternative spectra will be missed. And if you take about of CO, this is 16 and let's say this is 18. On that case, these and these are not same. So here peak will come, normal spectra is observed. Spectra is observed. Okay. So today up to this. Thank you.